Alrighty, so far we've done a few things here um, that I kind of want to just take a look at because as the program has expanded, there's a few things that really, in a lot of ways, uh, should change just for the continuation of this program here. So what I'm doing is I'm erasing fixed update off of paddle and the ball here. Unnecessary to have it there. Main reason is they both do the same thing. And remember, if something does the same thing, you should probably put it inside of the area. And in fact, fixed update and update here probably don't need to be here either. And I should be able to do something like that. Come back to entity here. We don't need to override update whatsoever. So, we just kind of trim the program a little bit. Now, do we need the ball to be the player type of stuff? No, we don't. That was an example. And I was just kind of showcasing, in a lot of ways, the approach here to maintain scalability. So I'm going to make clean, clear, and make. Program should still build, should still run. And this box here should still collide with the other box. And of course, we are I'm just kind of showing in this tutorial how you can both make a game yet keep it compatible for future games. So of course your Pong stick doesn't move like that. Of course, whatnot. But here, the main thing is the ball and the paddle render differently from each other. They have different component usage, but overall, they both use a fixed update, they both use an update, and that can be placed inside entity. And the transform component, of course, you could have all these variables placed right inside of entity itself. Again, tomato, tomato. At the end of the day, you really get to choose what you want to do in a lot of these ways. Now, why did I put radial and AABB here instead of over in like globals or even better in like math library? Well, there's a few reasons. Math libraries using vectors, where these things are using our transform component. At the end of the day, needed a decent way to grab this stuff. Really, this is fine. Now, the last thing we really want to do is determine collision between the ball and the box. Now, there is what is called separating axis theorem. And this has kind of a bigger learning curve. And for an intermediate programming tutorial, I'm not going to go over that. In fact, we're actually going to make our own custom collision system for ball meets box. SAT, separating axis theorem, is great for triangles. It's great for polygonal collision detection. The main thing is, because it needs to recalculate the normals to determine collision every frame, it's quite costly. And for games, they typically don't use it, believe it or not. Because if you look at like Unreal Engine, even though all those polygonal faces have face normals, it would be foolish to use those to detect collision at runtime. I mean, it would be way too slow. That's why you see stuff like a box collider, a cylinder collider, a circle collider. And in fact, the more precise collision you want really is based off of the type of program you're trying to write. In this case, I mean, you guys are writing Pong in a basic game engine style system. You don't need something crazy at the end of the day. In fact, you could create one, and that's exactly what we're going to do. Why did I do AABB and radial collision? Well, for one, just kind of showing how they work, and two, because we're going to kind of do a combination of both, and having an understanding of one and the other is going to be helpful for creating what we're going to do. So, inline bool custom collision, and we're going to take in our values here. Now, in this case, there's going to be a couple things checking for collision. It's going to be my box, as in the player's box and the ball, and the opponent's box and the ball. So the ball is really the shared factor. It's not going to be box to box in Pong. That, just kind of goes without saying. But my left-hand side in this case is going to be, it's going to be the box. And the thing is, you can never have both boxes colliding with the ball at the same time in Pong. There's no way. In fact, there's going to be a significant portion of time when they certainly cannot collide. And once you collide with one box, you would have to collide with the other box to collide back with the first box type of stuff. That's just kind of an interesting tidbit that we might be able to use. But what I'm going to do is save a few things. So we know that up here, this is our left-hand side's position data. It's kind of like where we're at size-wise. And we also know that we want to find the magnitude between the 2 points based off of our radius. And the nice thing too, if we look over at draw circle V, we ask it for its center and then its radius. So if its center is what we're saying is its position, its left-hand side is its center minus the position. Its right-hand side is its center plus the position. We don't really necessarily have to worry about the top and the bottom. In fact, it would be foolish to include top and bottom in this case because you're never going to use it. The ball is always going to be getting hit on the left or getting hit on the right. That's kind of a nice thing here. So our right-hand side is, if it's the ball, its position minus the right-hand side's radius. This is going to be right-hand side's left. And then vice versa for the left-hand side's right. See in here, this would be its position.x. Like so. And then we check the magnitude. So here we can check the magnitude like this. The left-hand side's position. Just kind of actually taking a look here. These are float. Yeah, honestly, I don't think we want to use magnitude. my left, your, or my right, your left type of thing, right? My left, your right. So if, let's start with if. So if my left-hand side left is, you know what? I want to start with my right because it would be easier for me to think about. If my right-hand side of my box is less than your left, so if it's less than your right-hand side's left, then this would be a true collision. And similarly, if my left-hand side of my box is less than right-hand side would be greater than or equal to. Yeah, okay. Right-hand side is right. This would be also true, I believe. You know, otherwise it would return false. But in this case, I want true here. I'm going to swap these signs. Do a false, like so. And do a custom collision. And come over here and do should just be able to type in custom collision here. So custom collision. We want to check 0 and 2. See if this collides. Yep, so that's a collision. And then my left-hand side. That's hilarious. Check this out. False. True. 1. And that's going to get us over to that other paddle. Yeah, let's see. All right, so that's successful. Now, we don't necessarily want to set the position, last position, blah, 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 right? That isn't technically what's going to be happening here. There's going to be a different thing. So let's go here. I want my player on my left-hand side. That's more typical of this scenario. And we want 0 and 2. We want 1 and 2. And then for the actual collision resolution, we want its direction of that ball to be changed. So I'm just going to grab that there and say, hey, you know, if this happens, your direction, because we know, hey, if you collided with the left Pong, your direction in the X is going to be 1. But if you collided with the right Pong, your direction in the X is going to be -1. And if we come up here, we could say, you know, give it a starting direction over here in ball. So let's just say you're going to go to the right first. You're going to go to the right first with a speed. So here. Actually, speed should be right. Just gonna look here. Aha. So what I just did there is I realized, because if you are the player, your direction is going to be this. Well, if you weren't the player, it's always going to be 0, 0. So when we start it at 1, as in, we said, hey, go ahead, ball. Your direction is going to default to 1. As soon as it updated, I said, nah, it's 0. So I just kind of moved that around for this test here. So it's going to start to the right. And when it collides, it'll bounce back to the left. And back to the right. So this is, kind of Pong in some ways. In other ways, it is definitely not. So let's finish this up.